So today we've played our ladybug dice game, and if you threw a 6 you got a body, a 5 a head, a 4 antennae, 3 the spots, and 1 and 2 you got the legs. And then we collected the data of the number of times you had to throw the dice to draw the ladybug. So the first two results were 27 and 30. Next results, call them out. Who hasn't? 24.
28.
14.
17.
20.
21.
5.
You're just calling random numbers because you actually have to do 14 to draw the beetle bug. Can we move to the next group?
32.
Say again? 22?
Yeah. 32.
Say again?
32.
32?
Yes. 32.
50?
Oh.
23?
45.
45? Thank you, nice clear voice.
24.
22?
1.
Ethan, yours?
21. 28.
Nicely said, Logan. Harry?
21.
That wasn't the same one, was it?
Yeah, I was missing.
Yeah, I can't have the same thing twice. That if you did it together, I only get the result once. Renard?
61.
61. My gosh, you must have got frustrated. They were waiting for a particular number to come up.
31
Any others?
and 35.
Well done.
I did 5.
Gone.
Say again.
I did 5.
85.
No, I did 5 of the things. Did I just do that one?
Yep. No, read out all 5.
35, 35, 22, 45, 23.
Was it 45?
Yeah.
Yeah.
23, 17, 17, and 14.
Wow, you were lucky.
33,
Okay, hang on. So we've got 33,
28,
28,
37,
37,
38.
and 38. And no.
21,
Yep.
27,
Yep.
22,
40,
40
and 31.
and 31. Okay, now what we do is we are looking here at GeoGebra. We're going to grab that and we're going to do one variable analysis. And that's quite interesting, the histogram, isn't it? And we can actually change those classes. But what I'm going to do here is look at the box plot. I could look at a dot plot. I don't seem to be able to get them both on the same thing. So we'll look at our box plot, and what does that tell us? Our mean is 28.5. So if we added them all up together and divided by the number, and the number is 38, we had 38 pieces of data, then the average is 28 dice throws. It's a box and whisker, yeah. And our minimum was 14 and our maximum was 61. Now I actually prefer a dot plot and a box plot on the same thing. So I'm actually going to use a different piece of software. Okay, so what I did there is I actually saved the data to Excel and then I picked it up using InZight. Now at home you can use GeoGebra and you can use InZight for free. You can just Google them, download them and play with them. So what I've got here through InZight is actually the picture with the dot plot at the top. So remember, somebody got around 60, somebody else got around 14. And then here we have our average, or we can get our summary, can't we? So we have our minimum of 14 and our median of 28.5. And we've got our first quartile and third quartile, or lower quartile and upper quartile. We have a standard deviation of 10.3. Sample size 37. Okay, so this one, because I've got my box plot and my dot plot on the same graph, it tells me more of a story about that data. What do you notice about this data? Question 1, is it symmetrical, yes or no? No. So where would you say the tail was to? Is hands up tail to the left? Hands up tail to the right? Yes, tail is to the right because here's the bulk of the data. The tail is spread out to the right. So 50% of the data, if I just grab that and Control V, pop it in there. Can you see that the bulk of the data is in here? So 50% of the data is here. This bit here is shorter than that bit there. That's more spread. So this is called the tail, because nice long tail. So the tail is to the right. You could also say it is skewed to the right. Okay? Now, we know why we've got the minimum. Is there any maximum? You could go on forever, theoretically, couldn't you? But apart from that, what's the shape of this data? It's kind of quite random, isn't it?
Yeah.
Yeah. And so you don't really see a symmetry. It's certainly not bell-shaped.
No.
In some respects, it's sort of almost kind of uniform through here, with then a few extras to the right.